Okay, so this is going to be the first word problem for chapter 10. It says a person can apply a maximum force of 80 pounds and needs to lift a 1,000 pound load with a lever. Part A, what is a mechanical advantage? And part B, if the fulcrum is zero 0.5 meters from the load, how far from the fulcrum must the force be applied? So let's just write down what's given. So we have a 80 lbs, so that's a force, and we have 1,000 lbs, so that's another force, and we also have 0.5 m, so that's some kind of a distance. So let's just try to draw a diagram to see what's happening here. So it says a lever, so you have a plank and you have a fulcrum here. And when you read the word problem, it says that so the 80 pounds, that's the force that the person applies. So the applied force is 80 pounds, so the applied force is going to be this one. And you want to lift 1,000 pounds, so the load is over here, and that's what you want to lift. That's going to be F load, which is 1,000 pounds. And next, for part A, we want to find out what is the mechanical advantage. And for part B, we want to find out, well, it says the fulcrum. The fulcrum is 0.5 meters from the load. So this distance here from the load to the fulcrum is 0.5, so our load is 0.5. So this X here is actually our load. And we want to find where the force is applied, so we're trying to find RA. This one there. So the equation for this setup is applied force multiplied by applied distance is equal to load force multiplied by load distance. And we just have to plug in here. Actually, and there's also one more equation because we want the mechanical advantage. So also we have the formula applied force multiplied by mechanical advantage is equal to load force. So that one always applies for simple machines. So for part A, we want the mechanical advantage, so we'll use this formula here. So applied force is 80. We're trying to find the mechanical advantage, and the load force is 1,000. So the mechanical advantage is going to be equal to 1,000 divided by 80. So that's going to be 12.5. So whatever force you apply, the lever is going to amplify by 12.5. So that's the answer for part A. And for part B, we want to get the applied force. So there we'll use this formula here. So we want the applied distance, so we're going to use this formula. So let me just write down the formula again. So applied force multiplied by applied distance is equal to load force multiplied by load distance. And let's just plug in. Applied force is 80. Applied distance, that's what we want. Load force is 1,000. And load distance is 0.5. So if you do the algebra, you solve for RA. That's going to equal 1,000 times 0.5 divided by 80. And that should give you around 6.25 meters. So now let's go ahead and do the next word problem. So this word problem says, how many pounds can a pulley with 10 strings lift when 5 pounds is applied? So let's just write it down here. So the first number is just 10, so that's just a number, so I'm just going to write it as N for now. And then we have 5 pounds, so that's a 5 lbs, so that's a force. And that's about it. So now it says pulley, so let's try to do the setup for a pulley. So you have the load that you want to lift, and it's connected to a pulley. And in this case here, from the pulley, you have 10 strings. So I'm not going to draw 10 of them here, but the number of strings is 10. So that's just going to be the number of strings here. And so you apply 5 pounds. So the force that you exert here to lift this thing is 5 pounds. So this is the applied force. And try to figure out how much of a load can you lift. So for a pulley, we're going to use the equation applied force multiplied by mechanical advantage is equal to load force. And we're also going to say that for a pulley, the number of strings is equal, or the mechanical advantage is the same as the number of strings. So we can just plug in here. Let's see. Applied force is 5. So mechanical advantage is 10. And that's going to give you the load force. So that tells you that you can actually lift 50 pounds.